its inception in July 1958, Universal Narratives has been your window to the captivating world of space exploration. The U.S. government's substantial investment of nearly $650 billion in NASA funding has paved the way for remarkable space missions, including the iconic Voyager 2 spacecraft. On that fateful day, August 25, 1989, Voyager 2 embarked on an unprecedented journey, making a close flyby of Neptune, an event that remains unrivaled to this day. For decades, Neptune had been shrouded in mystery, its enigmatic allure captivating the imaginations of astronomers and scientists alike. Now, a groundbreaking revelation has sent shockwaves through the scientific community. New information about this distant planet challenges our most fundamental understandings of the cosmos. What is it that scientists have recently discovered about Neptune that has left them in awe? And why do experts now believe it's high time to revisit this mysterious world? Join us as we embark on a thrilling journey of exploration and discovery, unlocking the secrets of Neptune and unraveling the mysteries that have long eluded us. Discovered in 1846, Neptune is a planet that stands out from any other in our solar system. This fascinating world is not visible to the naked eye, and was the first planet to be identified through mathematical predictions rather than empirical observations. Unlike Neptune, often considered Earth's twin, Mars is actually more similar to our planet. However, if we are looking for a true twin for Neptune, we must turn our attention to Uranus, its neighboring planet. Although Neptune is physically smaller than Uranus, it is much denser and lacks a well-defined solid surface, mainly composed of gases and liquids. The discovery of Neptune originated from earlier observations of the orbit of its twin, Uranus. In 1821, the French astronomer Alexis Bouvard published astronomical tables representing Uranus's orbit. However, he noticed significant discrepancies between these tables and actual observations. Nevertheless, he did not further pursue this discovery. In 1846, British mathematician and astronomer John Couch Adams and French astronomer Urbain Le Verrier began working independently on Uranus's orbit. Both of them calculated the existence of a new planet based on mathematical evidence. Their research led Le Verrier to write to Johann Gottfried Galle, an astronomer at the Berlin Observatory, asking him to search for this new planet using the observatory's telescope. This search led to the discovery of Neptune. Initially, there was a debate over who had actually discovered the planet, with tensions between the French and British scientific communities. In the end, an international decision credited both Le Verrier and Adams. Initially, Neptune was known as the planet outside Uranus, or Le Verrier's planet. However, the international scientific community eventually agreed on the name Neptune, inspired by the Roman god of the sea, considering that this planet was the farthest known, at least until the discovery of Pluto in 1930. The internal composition of Neptune shares some similarities with Uranus. It is predominantly composed of ice and rock, with a central core made of iron, nickel, and silicates. Its mass is approximately 1.2 times that of Earth, with a central pressure reaching 700 gigapascals. Like Jupiter and Saturn, Neptune is a gas giant, with an atmosphere mainly composed of hydrogen and helium, along with traces of hydrocarbons and nitrogen. Neptune's atmosphere represents only 5 to 10% of its mass, but this percentage increases deeper into the core. Descending into Neptune's atmosphere, higher concentrations of methane, ammonia, and water are found. Neptune's mantle, with a mass about 10–15 times that of Earth, is primarily composed of water, ammonia, and methane, forming a thick, warm, icy mixture known as the water and ammonia ocean. Within the mantle, it is believed there is a layer of ionic water, where water molecules split into hydrogen and oxygen ions. In the upper depths of the mantle, methane may decompose to form diamond crystals, which could fall like hail. This feature has led scientists to imagine what it would be like to fish for diamonds from a lake. Furthermore, there are theories suggesting the existence of a floating liquid carbon layer within the mantle, which, if confirmed, would make Neptune even more mysterious. Neptune appears blue due to the traces of methane in its outer regions and light scattering. However, Neptune's blue is more intense than that of Uranus, due to the planet's more active and thinner atmosphere. Studies conducted by the Gemini Observatory have revealed active and visible weather patterns on Neptune. Powered by incredibly strong winds with maximum speeds of 580 meters per second. Its distant position from the Sun makes it one of the coldest places in the solar system, with temperatures dropping to minus 218 degrees Celsius in the upper clouds and rising to around 5,100 degrees Celsius in the core. Additionally, Neptune is surrounded by a system of faint rings known as arcs, adding further nuances to its enigmatic nature. A unique aspect of Neptune is the inclination of its magnetic field, which is tilted by 47 degrees to the planet's rotation axis and offset about 13,500 kilometers from its center. Scientists believe this unusual orientation is due to internal flows within the planet. Neptune also hosts dynamic storms, with winds reaching 600 meters per second. One of the most famous storms is the Great Dark Spot, similar to Jupiter's Great Red Spot, discovered by the Voyager 2 spacecraft in 1989. This storm covered an area of 13,000 by 6,600 kilometers, but when the Hubble Space Telescope observed Neptune 5 years later, the Great Dark Spot had disappeared, replaced by a new storm in the planet's northern hemisphere. Among other notable storms is the Scooter, a group of white clouds located south of the Great Dark Spot. Despite Neptune's significant scientific interest, no dedicated space mission to closely study the planet has been undertaken thus far. The Voyager 2 spacecraft was the only space probe to perform a flyby of Neptune on August 25, 1989. This close encounter provided valuable data about the planet, but there is still much to discover. To address this gap, NASA is currently developing the Neptune Odyssey project, representing the next dedicated orbital mission to explore Neptune and its moons. This mission is designed to answer several fundamental scientific questions. How do the interiors and atmospheres of ice giants like Neptune form and evolve? What is the origin of Neptune's unique magnetic field, and how does its magnetosphere function? Is Triton Neptune's largest moon an oceanic world? What causes its geysers? What is the nature of Triton's atmosphere, and how can it contribute to our understanding of dwarf planets like Pluto? What are the connections between Neptune's rings, arcs, surface erosion, and small moons? The mission plan for the Neptune Odyssey, one of the upcoming great feats of space exploration, requires meticulous planning and a broad time perspective. The current schedule calls for the launch of the Neptune Odyssey by 2033 using an advanced space launch system. But there is also the possibility of leveraging gravitational assist trajectories with the support of Jupiter, which could significantly reduce the travel time and advance the launch to 2031. Regardless of the chosen departure date, the final milestone for the arrival of the Neptune Odyssey is expected in 2049, involving a 16-year space journey. This extended period of preparation and travel is justified by the vast average distance between Earth and Neptune, which is approximately 4.5 billion kilometers. Navigating this interplanetary path requires not only the construction of a sophisticated spacecraft, but also detailed trajectory optimization, taking advantage of gravitational assist opportunities and managing long-distance communications. The immense distance poses a significant technical challenge, with radio signals taking several hours to travel between the spacecraft and Earth. Therefore, the mission will require considerable patience and technological expertise from the scientists and engineers involved. Currently, the only human visit to Neptune was made by the Voyager 2 spacecraft, which conducted a close flyby of the planet in 1989. While that mission was pioneering and provided important data about the planet, the Neptune Odyssey represents a new opportunity to study this fascinating world in more detail and comprehensively. The advanced technology, scientific equipment, and exploration methods planned for the mission will open new doors to understanding Neptune and its mysteries. However, Neptune's mystery extends not only to the planet itself, but also to Triton, Neptune's largest moon. Triton was discovered on October 17, 1846, just 17 days after Neptune's discovery by British astronomer William Lassell. Triton is the seventh largest moon in the solar system, with a diameter of 2,710 kilometers, and it is the second largest planetary moon, following Jupiter's Ganymede. What makes Triton even more intriguing is the fact that its orbit is retrograde, meaning it moves in the opposite direction to Neptune's rotation. This unique aspect has sparked speculation about its possible origin. The remarkable dynamism of Triton, the largest moon of Neptune, is a fascinating enigma that captivates the attention of scientists and astronomy enthusiasts. Unlike many other moons in the solar system, Triton's surface is notably devoid of craters, suggesting relatively recent and ongoing geological activity. This feature makes Triton a dynamic world, in constant evolution and transformation, despite its distant location from the Sun. Triton's composition is dominated by frozen nitrogen, creating its thin but unique atmosphere. The surface is primarily composed of a water ice crust, a material found abundantly on many icy moons and planets in the outer solar system. However, what truly sets Triton apart is its highly active ionosphere, a thin layer of ionized particles that surrounds the moon. Triton's ionosphere is one of the most fascinating mysteries of the moon. It is much more intense and dynamic compared to that of any other known moon in the solar system. This fact is even more astonishing when considering that Triton is situated so far from the Sun, raising several intriguing questions. How can a world so remote and seemingly cold host such an active ionosphere? Scientists are engaged in the quest for answers to these questions and understanding the processes that fuel this extraordinary ionosphere. A key point of interest relates to the origin of the energy required to maintain such an intense ionosphere. In Triton's distant orbit, the direct contribution of the Sun to the ionosphere's energy is minimal. Therefore, scientists believe that other sources of energy must be involved. One possible explanation may lie in the interactions between Triton and Neptune. Triton is Neptune's only large satellite with a retrograde orbit, meaning it rotates in the opposite direction to the planet's spin. This unique orbit could cause significant interactions between Triton's and Neptune's magnetic fields, generating energy and electric charges in Triton's ionosphere. These complex processes are subjects of study and modeling by scientists. An intriguing hypothesis is that Triton may be an oceanic world, as it exhibits similarities with the geological activity of other oceanic moons, such as Jupiter's Io and Europa, Saturn's Enceladus, and Titan. The geysers observed on Triton's surface are believed to be caused by a subsurface reservoir of water that erupts through the thick, icy crust. This phenomenon could expand our understanding of where water might exist beyond our planet. To delve deeper into the knowledge of Triton, NASA has proposed a future mission called Triton, aimed at further exploring this mysterious moon. The mission intends to study Triton's surface in detail and investigate the ice geysers. One of the main questions the mission seeks to answer concerns the origin and nature of Triton's geological activity. In conclusion, Neptune is a fascinating planet with many intriguing characteristics, from its internal composition to its dynamic atmosphere and active weather patterns. Its nearby twin, Triton, adds an additional layer of mystery with its young surface and highly charged ionosphere. Future space missions, such as the Neptune Odyssey and Triton, will provide further opportunities to explore these distant worlds and unveil their hidden secrets, contributing to our understanding of the solar system and its enigmas.